Have you ever wondered what's really going on inside the mind of an algorithm? I mean, these systems are making huge decisions about our lives, about our healthcare, our finances, you name it. But what happens when they get it wrong, and nobody, not a single person, can explain why? Well, today, we're going to pry open that AI black box and talk about our emerging right to demand an explanation.
Okay, so to make this real, let's start with a story. This is Tammy Dobbs. She has cerebral palsy and was relying on a state program for 56 hours of home health care every single week. Then, one day, just completely out of the blue, those hours get slashed down to 32. But here's the thing, her condition hadn't changed at all. So what on earth happened?
Well, the reason was a brand new automated system that the state of Arkansas had started using. For Tammy, this one algorithm made a decision that completely upended her life. But when she and her lawyers asked for the logic, show us the math, they just hit a brick wall.
Yep, the decision was made by what we call a black box algorithm. Its inner workings were just so complex, so opaque, that the state itself couldn't give a straight answer for why her care was cut. And this isn't just some random one-off story. It's a preview of what can happen in a world run by systems we don't fully understand. So, to really get a handle on this, we're going to break it down into 5 parts. First, we'll define what this AI black box really is. Then we'll look at our legal right to an explanation. After that, we'll decode what makes an explanation actually useful. Then we'll check out the cool tools being used to create them. And finally, we'll see how this all plays out in the real world.
All right, first up, what exactly is this black box problem we keep hearing about?
At the heart of it is this idea: algorithmic opacity. It's kind of a built-in feature of a lot of modern AI. You see, the same complexity that lets these models find really subtle patterns in data also makes their decision-making process incredibly hard for a human to follow. It's like we can see what goes in, and we can see what comes out, but the journey in between, it's a total mystery.
So, faced with a world full of these mysterious decisions, policymakers aren't just sitting back and watching. They're starting to fight back with a really powerful new idea.
And this is where the law steps in. You've got these groundbreaking regulations, like Europe's GDPR, you've probably heard of that, and new rules coming out of California. They're establishing a legal right to explanation. Basically, they say that when an automated system makes a big decision about you, you have the right to get meaningful information about the logic involved.
Now, these laws really have 3 main goals. First, they let us make corrections. If there's an error on your credit report, you can challenge it. Second, they're meant to enhance transparency, to help build some public trust. And third, they help regulators understand the systems to check for big problems, like hidden biases.
Okay, so you have a right to an explanation. Great. But not all explanations are created equal, right? Getting a 500-page document full of code isn't really helpful to anyone. So we need a way to talk about what makes an explanation actually good.
This is where researchers came up with something called the legal XAI taxonomy, which is basically a fancy name for a decoder ring. It helps us sort explanations into different types, so we can ask for the specific kind of answer we actually need.
So the first dimension is all about scope. A local explanation is about your specific case. Think of Tammy Dobbs asking, "Why were my hours cut?" A global explanation, on the other hand, is about the whole system. That's like a regulator asking if a bank's loan algorithm is biased against an entire neighborhood.
Next up is depth. A selective explanation is the highlight reel. It gives you just the top few reasons, making it super easy to understand. But a comprehensive one gives you everything, the whole shebang. It makes sure nothing is hidden, even if it's a bit of information overload. So there's this constant trade-off between keeping it simple and being complete.
Now this might be the most important of all. Is the explanation something you can actually do something with? A non-contrastive explanation just tells you what happened. Here are the factors. But a contrastive one tells you what could be different. It answers that crucial question. What would I have needed to change to get approved for that loan? Now that is an explanation you can actually use.
So, we've got a framework for the kind of answers we want. Now, let's open up the toolbox and look at what computer scientists are building to actually get those answers. This whole field is called Explainable AI, or XAI. One of the classic tools in the kit is called permutation feature importance. The idea is actually pretty simple and kind of clever. You take one piece of data, like say the duration of a loan, and you just randomly shuffle all the values for it. Then you see how much worse the AI's predictions get. If the accuracy takes a nosedive, you know that feature was really important. This gives you a big picture, global ranking of what the model cares about most.
But what if you need that local explanation? What about just one person's case? For that, you might use something called Shapley values. This technique looks at a single decision and figures out exactly how much each factor pushed the final outcome one way or the other. So here, you can see that for this specific person, having a high credit amount was a big negative factor, and not having a checking account also pushed the decision in the wrong direction.
In this slide, this just maps it all out perfectly. It connects the tools to the types of answers we want. For that global, non-contrastive view, you've got permutation feature importance. For the local view, you've got Shapley values. And for those really useful, contrastive explanations, the ones that tell you what you could change, there are methods like counterfactual examples, which can literally generate a profile of a slightly different you who would have gotten approved. Each tool is built for a different kind of question. Okay, so the legal right is there, and the tech tools exist. That should be the end of the story, right? Well, not so fast. When we actually look at how this is all playing out in the real world, especially in a high-stakes area like finance, we see a major disconnect. So check this out. A fascinating study went out and interviewed people at major banks and the financial regulators who oversee them. When asked what info the regulators need, the banks focused on a pretty narrow list of technical stuff about the AI model itself. But the regulators, whoa, they said everything was relevant, from the data used to how the system was designed, all the way to who specifically is accountable for it.
This quote from the study really just nails the problem. The banks were thinking about model explainability, the technical guts of the machine. But the regulators were demanding system explainability. They want to understand the entire human process around the model, the governance, the oversight, the accountability, the whole picture.
And that's the real takeaway here. This isn't just a coding problem for data scientists to solve with a fancier algorithm. It's a communication problem. It's about getting lawyers, tech folks, and regulators all speaking the same language with a shared understanding of what it really means to explain an automated decision.
And that brings us to the final question, which is really a question for you. When a black box algorithm makes a decision about your health, or your job, or your money, what kind of explanation do you think you're owed? Do you want that big picture global overview or the nitty-gritty local breakdown of your case? Do you just want to know why, or do you need to know what you could have done differently? The answers we all decide on are going to shape whether our future is transparent and accountable.